tutorial I will explain a Simulink Stateflow tutorial on basically parallel decomposition in Stateflow. Okay, and I will use a air temperature controller to explain the parallel decomposition. Okay, and then I will build and simulate a state flow chart for an air temperature controller using a parallel state to model two fans and a speed controller. Okay, now you can see this is our two fans and this is our speed controller. Okay, and in state flow, state can be exclusive or parallel. Exclusive states are shown in solid rectangle. As you can see, this is power on, this is our exclusive on state. Okay, sorry, power off. And inside power on, you can see this is dashes rectangle. Okay, with exclusion order number. You can see this is exclusion order number 1, 2 and 3. Okay, and can be active simultaneously but execute serially. Okay, this will be active at a time, but it will be executed as we have assigned 1, 2 and 3. Okay, and you said parallel decomposition and by selecting parallel end on a parent state. Okay, and let's apply this to an air controller with two fans and a speed calculator all running concurrently when power on. Okay, here I'm simulating our model for the objective of our simulation today. Okay, and this is our scope output. Okay, this is our scope output. Okay? And inside our main model I'm simply explaining it. Okay, I will made this model from very beginning. Okay, and inside the power on operation I use two fan 1 and fan 2, and fan 1 will be power on when temperature is above 120, and fan 2 will be turned on when temperature is above 150. Okay, it's easy. And the speed value will calculate the airflow. Okay, now when I see the scope, and you can see the input temperature. Okay, when input temperature is 120, you can see the first fan 1 is turned on. Okay, now when the temperature is above 150, you can see the fan 2 start here. Okay, and you can see when fan 1 start on, you can see the airflow is 1. Okay, and when both the fan 1 and fan 2 start on, the airflow is increases to 2. Okay, and at a time and after time when temperature is below 150, as you can see this is below 150, and you can see the fan 2 is turned off. Okay, and our airflow is setting as 1, and our fan 1 is still turn on. Okay, and when temperature is below 120, as you can see both the fan 1 and fan 2 are turned off. Okay, so that's the basically we'll do in this tutorial. Okay, so I'm taking a new model. Okay, and we need a state flow. Okay, state flow is present under Simulink library browser, and this is under state flow, and this is our chart. Okay, okay, and this is our state. Okay, and I'm renaming it as like power off. Okay, and I'm setting as entry value airflow is 0. When power is off, the airflow will be 0. Okay, and I'm taking another block here and making it larger because this will be our parallel and operation block here. Okay, and I'm renaming it as power on. Okay, and I'm taking transition power off to power on when power equals 1. Okay, and from power on to power off when power equals 0. Okay, now inside power on we have to set it to decomposition, and this is by default exclusive for. Okay, and we have to set is parallel and. Okay, it's okay. Now we have to add our block. This is our, I'm renaming it as fan 1. Okay, and another block I need fan 2, okay, and inside fan 1 I need another block here, okay, and I'm taking it larger, okay, and this is by default off, okay, by default off, and entry value will like our fan 1 status equals when power is on and our fan 1 is off, so our fan 1 status will be 0, okay, and I'm taking another one to on, okay, and fan 1 status will be here as it is on, it will be 1, okay, and when the fan 1 will be start from off to on, okay, we have to give a transition when I'm taking temperature is above 120, okay, when temperature is above 120 our fan 1 will be start, okay, and from on to off when temperature is less than or equal 120, okay, so this is our fan 1 and this is our fan 2, okay. Similarly we need another block inside fan 2, and this is off, okay, and entry value will like en, this is fan 2, okay, fan 2 status as this is off, fan 2 status will be 0, okay, and we have to take another block, another state here, this is on, and fan 2 status will be 1, okay, and we have to give transition from off to on, and this is fan 2, okay, and I'm taking it like when temperature temp is above 150, okay, when temperature is above 150 the fan 2 should turn on, and from turn on to turn off when temperature is less than or equal 150, okay. Now we need another state inside the power on which will give us this airflow value, okay, and I'm renaming it as speed value, okay, and as this value will be update every time I'm taking during, and airflow equals in, okay, in basically gives a boolean output, it will gives 1 or 0 when fan 1 is on, okay, and we have to add fan 2, similarly in when fan 2 on, okay. So our model is almost done. We have to go modeling and symbol panel. I can see power is input, it's okay, temperature is also input, fan 1 status, fan 2 status output, and airflow is also output. So that's all we can resolve our symbol, and we have to go back to our Simulink, okay. For power I want to take a manual switch here, okay, manual switch here, and two constant block will be needed. This is power on, by default I am taking power equals on, okay, and temperature we need a variable temperature, okay. For that we prefer a stair generator block, and you will find stair generator block under electrical specialized power system, okay, and I'm connecting it here to temperature, and I need some value like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15, okay, it's a larger number, and each time I want to take amplitude 70 80 90 110 120 it will cover all the condition, okay, 130 150 160 190 and again 130 110, 110. Okay, now click OK. Sorry, there is sorry, I have mistakenly added two number extra. It will be up to 30. Okay, now click OK. Now you can see. Okay, then we need a scope. Okay, and scope input will be 4. Okay, and I'm choosing out. Okay, okay, this is a fan on status, fan 2 status, and airflow. Okay, I'm setting is fan 1 stat, and this is as fan 2 stat, and this is airflow, and this is our input power. Okay, okay, we have set all our parameter. Now it's time to run our model. I'm taking a 15 second and run our model. Now you can see what's going on inside it. Okay, it's on. I'm taking another run here. Okay, as the temperature is changing, you can see what's happening inside here. Okay, I'm opening my scope, and okay, let's change some setting. Power is okay to apply, then 3, it is red. Okay, and 4, this is cyan, apply, and 1, it's 2, it can be used as blue. Okay, okay, you can see our power is on always. Okay, I set it at 1. Okay, now you can see, sorry, we have to take temperature here. Power is not to see the or observe the output here. Okay, I'm taking as this is a temperature. Okay, okay, and run this model. Okay, now you can see as the temperature is increasing, when it's above 120, the fan 1 is started here. Okay, you can see, and our airflow is 1. Okay, now when temperature at this point is above 150, you can see here when this is above 150, fan 2 also started here. Okay, and at this stage the fan 1 and fan 2 both are running. Okay, and the airflow level is 2. Okay, now when the temperature is below 150, the fan 2 is immediately turned off, but the fan 1 is still turned on. Okay, now you can see here, and our airflow is 1, and when the temperature is below 120, both the fan 1 and fan 2 are turned off. Okay, so this is how you can model parallel decomposition. Okay, parallel decomposition instead of exclusive or operation. Okay, so that's all for today. Thanks for watching.